Hey guys, and welcome to part 2 of this React query tutorial. Let's have a look at the project we'll be building by taking a look at the completed version. We'll be building a classic to-do application with functionality to create a new to-do item. So as an example, let's write learn React query. And when we click on add, we'll see that there's a loading spinner, and then the to-do item has been added with a toast message in the bottom right corner. Then we can also complete the to-do item. And if we want, we can delete the to-do item. One thing to keep in mind is that the backend is already implemented for us because I wanted the purpose of this video to focus on React query. Before getting started, I want to mention that the GitHub repo can be found in the description of the video. If you navigate into the code folder, you'll see that there's a starter code and a completed code. If you want to follow along with this tutorial, you can clone the repo and open the starter code. Alright, so let's have a look at what's included in the starter repo. First and foremost, we have a backend folder. So if we take a look at the README, I've documented all the endpoints that are already written for us. In more detail, under the hood I used local storage and an API mocking tool called MSW, but you won't need to worry about that. In particular, we already have 4 endpoints implemented for us. First is the list to-dos endpoint, which just retrieves an array of to-do items. And the fields included are an ID, a completed boolean, and a description. Then we also have a create to-do endpoint, update endpoint, and delete endpoint. The next folder we can look at is the API folder. In here, if we look at the index.ts file, we'll see that there's a bunch of helper methods for calling the REST API. So for instance, we have a list function over here. And under the hood, it'll just call fetch with the base URL of the API. And then it'll check if the response is okay. If not, if we get like a 400 or a 500 response, we'll throw an error. Otherwise, we'll just simply return the data. There's also helper methods for the create, the update, and the delete. In this folder, we'll also notice there's a models folder. And if we open this, we'll see that there's just the type for the to-do item model and to-do list model. Next up, we have a components folder. In here, there is a input form and to-do list component. So if we look at either one of these, you'll see that I used a component library called ChakraUI to make these components. Don't worry if you haven't used it before, it's very intuitive. I've already added a bit of styling, so you don't have to worry about that either. Awesome. So now that we covered the starter code, let's see what the application looks like. You'll notice that when we click on anything, nothing works. And the reason for that is that we have hard-coded data so far. Our job will be to make this fully functional using React query. The first thing we should do is install React query. So we can enter the command npm install @tanstack/React query. When that's complete, let's navigate to the index.tsx file. There's a bit of setup that we'll need to do. You can navigate where there's the root.render, and we'll need to wrap everything in here inside a query client provider. So move the application inside this query client provider. We'll also need to provide it with a query client, and we can do that like the following. We can write const query client equal to new query client. And then don't forget to pass this in to the query client provider. Next up, let's write our first query to retrieve a list of to-do items. So first I'll make a hooks folder for our custom hooks. And then I'll make a new file called useTodosQuery. And this will simply wrap the useQuery hook from React Query. We can import that from @tanstack/React Query. And then there's a few arguments we'll need to provide. Remember, the first thing we'll need to provide is the query key. And this is to uniquely identify the data. In our case, it's just a simple to-do application, so the query key can be to-dos. And next, we'll provide a query function, and we can pass in our to-dos API .list. And creating a query is actually as simple as that. Now let's navigate to the to-do list component. In here, we can remove the hard-coded to-do list, because we can fetch data using our query now. So at the top of the component, let's write the following: const status and data equal to useTodosQuery. Now in more detail, the status will just tell us if it's in a loading state, error state, or success state. And if we know it's in a success state, we can pull that from the data. So let's add a few checks. We'll say if status is equal to loading, then we can return a loading message. We can do the same thing if it's in an error state. So if status is error, return an error message. Now that we've added these two checks, if we get past it, we'll know that it's not in a loading state and it's not in an error state, so therefore it's in a success state. And we can use this data property and come down here and replace hard-coded to-do list with data. Let's go back to the application and see the changes we made. It might look the same, but that's because I implemented the backend to seed data if the list was empty. So the data that we see here is actually from our backend. If you hit refresh, you'll even notice that there's a loading message right before the data appears. If you want to confirm this, you can head to the Network tab in the browser. Hit refresh again, and you'll see that there is in fact a network call to the To-Dos API. You can even double check the response here. So this confirms that our data is coming from the REST API. Awesome, so we completed the first step of this tutorial. In the next video, we'll have a look at mutations in order to create a new to-do item, update a to-do item, and delete a to-do item. See you in the next video.